Blocks of geometry. Let's go ahead and start with the warm-up. Look around the room you're in and see if you can find an example of each of these. Point, line segment, angle, line, and plane. A point, single location in space. You might be looking in your room and see that corner where the walls and the ceiling meet. That's a point. You might have a button on your shirt like mine. That's a point. An example of a point. Line segment. Line segment. In that corner all the way along the wall where the walls meet, that's a line segment. Along the floor, the baseboard, that's a line segment. An angle. Maybe you're looking at your computer screen, seeing these 4 angles on that screen. Line. A line continues indefinitely in 2 directions, and so if you imagine where those 2 walls meet, if you imagine that continuing up through the ceiling and down through the floor, that's an example of a line. Or imagine that floor, that corner, that baseboard continuing through those corners, through the walls. That's an example of a line. Plane, that wall, that's a plane. Piece of paper, that's a plane. Flat surface, it's an example of a plane. Your desk, that's a plane. The objectives for this lesson are to understand and identify the undefined terms point, line, and plane, define segment, ray, angle, collinear, intersect, intersection, and coplanar, and to investigate postulates about points, lines, and planes. Let's start with the undefined terms, or the building blocks of geometry. Those building blocks of geometry are points, lines, and planes. And the reason we call them the building blocks of geometry are because there are these 3 concepts, these 3 ideas that we describe, and then everything else in geometry builds off of those 3 ideas. These 3 values, or 3 items, points, lines, and planes, they're undefined. We just describe them. They don't have any size, they don't have any thickness. We agree to accept their so-called definitions or their so-called descriptions. And by accepting those, we're able to build properties and build geometry off those 3 ideas. So everything comes from points, lines, and planes. Everything in geometry comes from points, lines, and planes. Okay, points. Points are often shown as dots. So for example, I have this one down here. This is point P, point A, point X. When you name them, you have to use, or you need to use, they're named with capital letters, such as A or X. Now, unlike those actual dots we have, points are, they have no thickness. They're basically no size whatsoever. They're just location in space, if you will. If you look in that corner where the 2 walls meet with the ceiling, that tiny little right at the very intersection of those 3 planes, that's a point. Or way down in the corner, as far as you can go in that corner, that's an example of a point. Lines, they don't have any thickness. They're going to extend in 2 directions forever. Lines are perfectly straight, so if it's curved, it's not a line. When you name a line, you name it with 2 letters, so 2 capital points, or in this case, XP, and you put a double arrow over the top. The double arrow shows the reader that it's going in both directions forever. Now, it doesn't matter if you name this XP or PX. You can write the word line XP, line PX, or you can name it with a lowercase letter, in this case, line M. So line goes in 2 directions forever. No thickness, perfectly straight. Planes extend in all directions along a flat surface forever. So that piece of paper, that's an example of a part of a plane. If you imagine that piece of paper extending forever in all directions, that would be a plane. When you name a plane, you name it with 3 points. Here I've got points M, N, and O, so I can name it MNO, OMN, NOM, whatever you want, any order you want, name it with 3 points. Or you can use a script, capital letter, in this case, R. So, planes. Collinear and coplanar. Collinear means that they're points that are on the same line. So, for example, if I have points A, B, C, and then D. Points A, B, and C, those are all collinear because they're on the same line. Point D is not collinear with A, B, and C because it is not contained on the same line as A, B, and C. Coplanar are points that are contained in the same plane. So if you imagine 3 points on the floor of the room you're in and a couple points on the ceiling, the points on the floor are coplanar, the points on the ceiling are coplanar, but together they're not coplanar. So coplanar means that they are on the same plane. Collinear means they're on the same line. Collinear, same line. Coplanar, same plane. All right, a segment. A segment is a part of a line with 2 endpoints. So you're going to take the line and you're going to chop it so that you only have a portion of it, 2 endpoints. It's not going to go forever in both directions. When you name it with the endpoints. So I've got endpoints F and E. I'm going to name it F, E, or I can name it E, F. And what you do is you put a segment bar over the top, no arrows. You can write out the word segment FE, segment EF, or use the symbol notation. Just a single little bar over the top, no arrows, because those are endpoints of the segment. It stops. A ray is also a portion of a line, only this time we have 1 endpoint and it goes forever in one direction. So this ray that I have is ray GH. When you name the ray, you can write out the word ray, endpoint, and then other point, or the 2 points with a single headed arrow over the top. The arrow always points to the right, no matter what direction your ray is going in. If I have ray A, B, I name it, end point first and then the other point. Arrow always goes to the right. So the arrow is not telling you what direction the ray is going in the picture. It's just telling you that G is the end point, go in the direction of H. Or A is the end point, go in the direction of B. A ray is a part of a line. 1 endpoint extends indefinitely in one direction forever. An angle. A figure formed by 2 rays with a common endpoint. So I've got ray BC and I have ray BA. That common endpoint is B. When you name an angle, you name it with 3 letters. The symbol looks very similar to a less than sign. It's a little different. The bottom's a little bit more flat. Name it, start on one ray, then the vertex, then end on the other ray. Vertex always goes in the middle. We could also call this angle CBA. We could call this angle B. Sometimes you're going to see a 1 or a number inside. We can call this angle 1. Now if you have more than one angle at that vertex, so let's say I have D, E, F, and G. Here I said we can name this angle angle B. Notice there's only one angle with vertex B. Well, if I name angle E on my second drawing here, is it clear what angle I'm talking about? There's lots of angles with vertex E. There's this little angle, there's this little angle, there's the large angle. So it's not clear which angle I'm talking about by using just one letter. And so the only time you can use one letter to name the angle is if it's the only angle with that vertex. This was the only angle with vertex B, so I could call it angle B. You name it with 3 letters, start on a ray, vertex in the middle, end on a ray. Let's go ahead and practice. Here I've got this first one, a line, so I'm going to call it line XY. Using the symbol notation, I'm going to put a double arrow on the top because it goes in both directions forever. I could call it line YX. Order doesn't matter with a line. I can write out the word line and then have either XY or YX. B, I've got a segment. I can write out the word segment and then the 2 letters in any order that I want, because with a segment, order doesn't matter. Or I can use that symbol notation, PQ with a single bar on the top, no arrows, or QP with the bar on the top, no arrows. C is a ray. I have ray, MN, this time order matters, end point and then the other point. So the only way I can name C here is by having the arrow over the top, MN, so that's ray MN, or I can actually write out the word ray and then my 2 points, end point and then the other point. Order matters with rays. D, that's point Y, so just Y. Let's try it with some angles. Here I have angle 3. On F, we have angle X. G, I've got several options. I can call it angle R because it's the only angle with R as a vertex. I can call this angle PRQ. I can call this angle QRP. Vertex has to be in the middle. H, that's a plane. So I've got plane RTS, plane TSR, plane SLR, any combination of those 3 letters, doesn't matter. Any order, doesn't matter. Now if this L were a capital script L, then we could say plane L and not have to use 3 letters. We have some postulates. The first one here, the intersection of 2 lines. Well, let's look. If this represents like a rectangular box, prism, or a room that you're in, so a rectangular room, if you take 2 lines that cross, so here's 2 lines that cross, well, their intersection is a point. Notice if I pick 2 other lines, their intersection is a point. So the intersection of 2 lines is a point. The intersection of 2 planes is a, well, let's look at this ceiling or the top of my box here. And we'll look at this wall or the side. So there's 2 planes, and they intersect along that line. So the intersection of 2 planes is a line. Through any 2 points, there is exactly one, well, I've got a point, and I have another point, and there's exactly one line that contains those 2 points. If I pick this point and this point, there is exactly one line that contains those 2 points. Through any 2 points, there is exactly one line. Now, if I were to pick this point and all the way down to the bottom, so I've got from the upper corner to the bottom corner of a room, there's one line that's going to go through that. It's going to go through the center of the room all the way. Imagine this line crossing diagonally through the room. So through any 2 points, there is exactly one line. Through any 3 non-collinear points, well, 3 non-collinear points means that they can't be on the same line. So, well, those 2 are on the same line, so I'll pick this one over here. It's not on the same line as the other 2. Through any 3 non-collinear points, there is exactly one plane. If you pick any 3 non-collinear points, there is exactly one plane that will contain all 3 of those points. If 2 points are in a plane, then the line containing them. So if I've got 2 points in a plane, these 2 points are both on that ceiling. Here, I've got the line containing them. Notice that line is also along the ceiling. So if 2 points are in a plane, then the line containing them is also in the plane. 2 points in a plane, they both share this plane. The line containing them is also in that plane. So if you imagine 2 points on the floor, in the middle of the floor somewhere, and you draw the line to those 2 points, is that line also on the floor? Yeah, it's going to be. If you have 2 points in a plane, the line containing them is also in the plane.